Yes. Yes. Can you remind me in a couple minutes? Um, I had a really dumb idea last night. I was thinking, what graphic could I put up here for a warm up? And I was thinking, it's cold, warming up, a s'more would be really fun. And then I got to thinking, that's really what we should call warm ups, s'mores, because it's the more practice on all this. So yes, I'm losing my mind. Okay. So at the bottom of 2B, there's a little exit ticket from yesterday, and I just wanted to talk about a few things. You don't have this problem, but how would you graph 1/2 to the x? Can anybody tell me, is this going to be a growth or decay? Okay, so give me 3 ordered pairs. You shouldn't need a calculator. Whoa, sorry, I'm not getting, oh, I didn't, did I hit? Okay, apparently I forgot I started the recording, so I have the stupid explanation of the s'more on the recording. Okay. All right, I think my cursor's finally working. If you put in a 0, you get out a 1. That is correct. If you put in a 1, you get out 1/2. If you put in a -1, it flips it over and you get out a negative exponent, right? 0, 1, -1, 2, 1, 1/2. Is it linear? Because it kind of looks linear here. It's linear? No. If we put in a -2, what would we get out? You flip it over and square it, get out a 4. So it's doing this. So walk me through, I don't even care about parent functions, transformations, domain. Yep, all real numbers, range. 0 to infinity. Does it have an x-intercept? The y-intercept is at 0, 1. Asymptotes? Which is? End behavior? Left end? What is the left end doing, guys? It's going up. So as you go left, it's going to approach infinity. As it goes right, you're going to approach 0. Is this increasing or decreasing? Okay. This is like a homework question, and it's possible it's like the one that Moira asked about. I'm not sure. We did one like this yesterday. You actually have this question, okay? So you might want to try to squeeze a little work in at the bottom of 2B. Is it on 2B? Yes. Yeah. All right. It says we're to figure out the question on a quiz would say find the rate that it's growing at. So we have this idea, y equals original times 1 plus or minus some rate to the time. Okay, so what is the original? Okay, we don't know what the rate, it is growing though for sure, right? Because it came 4,000. We know how long did it take? 2 hours. And what did it become after 2 hours? 4,000. So this is easier than the one yesterday because it's not a power of 10. But what do we do first? Divide by 100 so that we have 40, right? 1 plus r squared. Then what? Yep, square root or 1/2 power. What? Sometimes I get myself in the weirdest. Okay. Square root of 40. Okay, 6.324. Then what are we supposed to do? Yeah, 6.32 equals 1 plus r. If we subtract a 1, we have 5.32. What percent of growth is that? Nope. Normally we get like 0.07, right? This is, yeah, this is 532% growth. Does that make sense, guys? It's growing really fast, right? All right. So we're supposed to figure out 7 p.m. So let's go back and write an original equation. Y equals 100 times 1 plus 5.32 to the, from 2 p.m. until 7 p.m. would be how many hours? 5 hours. I hope that's one of the choices. Somebody typing? Is it a choice or not? Not even close? Five hours. I divided, right? Yes? This was 40. You got close to H? A million and something? Okay. Well, and they may have rounded differently along the way, so we'll go with it's close. All right, moving on. This is 79. You have this one as well. Is this a growth or decay equation? Decay. All right, so if it's decay, then our a, b to the x, what should b be? More than 1 or less than 1? Less than 1. So we're down to choices what? G and H, okay? So this is the point that's making me think we can figure it out. How do we find that point? On the y-axis, so we put in x equals 0. So if I put a 0 in here or here, which one would give me out 0, 2? H? Half to the 0 would be 1, right? 1 times 3 is that G. Yeah. All right. Just because you don't have this. This is bookwork. Were you assigned any on 11 through 15 last night? I don't have it updated. You had to do 13 and 14? Okay. So these are actual homework questions. Describe, you're supposed to graph them, a sketch of them as well, but describe the transformations, guys. What? Anybody describe the transformation from the parent from F to G? It's a reflection where? Yes. Reflect over X. And what does a 2 on the whole thing do? It's a vertical stretch. You're also supposed to sketch this. What two things are going on 14? I'm not even going to write it down. Right 2, up 5. Yep, right 2 and up 5. Which would change the asymptote to what? Y equals 5. Nice job, Moira. All right. Did you have to do any of these yet? 53 through 55? Y'all 3 of them? Okay. So somebody pick one. 55. 4 to the x is reflected in the x-axis. What would that do? X-axis. No, wait. X-axis. Yes, you're absolutely right. A negative in front. Okay. And then 1 to the left. Good job. And 6 up. All right. So we did a few homework questions together. Let's move on and talk about worksheet 3. This is just a warm-up because some of you desperately need to retake 2.5b. You don't have this question? Anybody remember how we do this stuff? Okay. If we take out an a down here, what is the common denominator? Times a. So we have an a and an a minus 1, an a and an a minus 1, an a and an a minus 1. And we're multiplying it by this fraction, which was a plus 2 over a and a minus 1. Then we're multiplying it by 1. Then we're multiplying it by the fraction 1 over a minus 1. Okay, I don't know. I have a lot of parentheses there. All right. So over here, the denominator divides out, and we're left with... Okay, some of you got real wonky when it was multiplied by a constant. Yeah, this is just 1 over 1, so we end up with this. Can you distribute since we don't have much space? Yeah, if you multiply this by 1, it does nothing, so you just get a squared minus 1a. Plus, what happens back here? A times 1. Yes, we're multiplying. So we get a. So we have a squared. These will drop out. I'm going to leave a 0 over here. So I'm going to leave a positive a squared minus an a and a minus 2. Subtract those over here. How does that factor? A minus 2 and a plus 1. Is that right, guys? All right, so we get a equals 2 or negative 1. Is that okay? Actually, it is, right? Because a can't be... Yeah, a can't be 0 or positive 1, but these should both work. All right, some of you, a lot of you, need to retake 2.5a. B, just kidding. Maybe a too, but... All right, worksheet 3. We're going to talk about graphing logs. Guys, the big issue, why did they ever invent these silly log things? Okay? Logs are the inverse of exponential sentences. That's what you need to know. Everything has to have an inverse, a way to undo it. Okay? And when we are looking for the amount of time it takes from 6 cells doubling to get to 100, so you'd put 100 over here, you're looking for x. When you're looking for an exponent, you need a log to solve it. These are inverses, okay? So the same is true when you go to graph them. All right, so let's see. The graphs of exponential functions passed the horizontal line test, so they were 1 to 1. So their inverses will also be functions. The inverses are logs, all right? So this is just showing you an exponential growth. And this would be log base b of the same thing, the inverse. So y equals b to the x. If you rewrite that as a log sentence, let me see. First of all, let's switch the x and the y to find the inverse. Then does anybody remember how you rewrite that as a log sentence? It's log b of x equals y. All right, so they are undoing each other. And for your entertainment this morning, I have a really
small numbers. How does the difference between 0.00000000398 and 0.00000000398 cause one to have red eyes after swimming? To answer this, we first need a way of dealing with rather small numbers, or in some cases extremely large numbers. This leads us to the concept of logarithms. Well, what are logarithms? Let's take the base number b and raise it to a power p, like 2 to the third power, and have it equal a number n. We get an exponential equation, b raised to the p power equals n. In our example, that'd be 2 raised to the third power equals 8. The exponent p is said to be the logarithm of the number n. Most of the time, this will be written log base b of the number equals p to the power. This is starting to sound a bit confusing with all the variables. So let's show this with an example. What is the value of log base 10 of 10,000? The same question could be asked using exponents. 10 raised to what power is 10,000? Well, 10 to the fourth is 10,000. So log base 10 of 10,000 must equal 4. This example can also be completed very simply on a scientific calculator. Log base 10 is used so frequently in the sciences that it has the honor of having its own button on most calculators. If the calculator will figure out logs for me, why study them? Just a quick reminder, the log button only computes logarithms of base 10. What if you want to go into computer science and need to understand base 2? So what is log base 2 of 64? In other words, 2 raised to what power is 64? Well, use your fingers. 2, 4, 8, 16, 32, 64. So log base 2 of 64 must equal 6. So what does this have to do with my eyes turning red in some swimming pools and not others? Well, it leads us into an interesting use of logarithms in chemistry, finding the pH of water samples. pH tells us how acidic or basic a sample is and can be calculated with the formula pH equals negative log base 10 of the hydrogen ion concentration, or H+. We can find the pH of water samples with hydrogen ion concentration of 0.00000000398 and 0.00000000398 quickly on a calculator. Punch negative log of each of those numbers, and you'll see the pHs are 7.4 and 8.4. Since the tears in our eyes have a pH of about 7.4, the H+ concentration of 0.70398 will feel nice on your eyes, but the pH of 8.4 will make you feel itchy and red. It's easy to remember logarithms. Log base b of some number n equals p by repeating the base raised to what power equals the number. The base raised to what power equals the number. The base raised to what power equals the number. So now we know logarithms are very powerful when dealing with extremely small or large numbers. Logarithms can even be used instead of eye drops after swimming.
Is it going to start playing a video all by itself if I leave that up there? All right, so this is how it's written in your book, but the way they said it makes a lot of sense. The log base b of a number equals the power, okay? Means the base to some power is the number. You have to be able to rewrite these. This is review, okay? It's at the top of your notes. You have to know this down cold. I don't know if that's an old lady saying, but so how would you rewrite this one? Okay. All right, go in the other direction. Hang on, I'm trying to switch to the next one. I'm just waiting. Log base, what's the base in this question? Okay, the base is A. Log base, the base is this number down here, of some number equals the power. So the power is 20. So the log, what's the base in this problem? It's base power number. Log base 7 of some number equals -3. The answer to a log is the power, the exponent. Questions? If you need, sometimes I just make people memorize it like this. If you can't remember all this goofy stuff, remember where every little thing goes. It's just showing that that's where you move the things around, okay? Some people get so confused. It makes sense to me, but if it doesn't make sense to you, just remember where they move to. Okay. If the base is greater than 0, okay, you can't have a negative base of a log, and you can't have 1. But the log of any base of 1 would be 0. This should make sense to you because b to any power is 1, yes? No. Then it says the log base b of b equals 1. That should make sense to you. B to the first power is b. These making sense? Okay, then it says log base b of x equals x. Oh, I'm sorry. I didn't write that one right. Try again. Log base b of b to the x equals x. The easiest way to explain this one is just think, do you remember the properties that we're going to talk about tomorrow? You can move this x out front. So then this we just talked about is 1. All right, and b to the log base b of x will cancel each other out and become x. Let me explain that one a little better. If I told you to rewrite this as a log sentence, what would it look like? You would write log base b of some number x equals the exponent. Is that true? Okay. That's why they undo each other. All right. Moving on. Those are same true. All of these properties are true for common logs. Common logs means base 10. Natural log means base e. Okay. Anytime you see plain old log, what's the base? 10. And anytime you see ln, it's really the same as log base e. It just has its own abbreviation, okay? All right. We just went through these. All right. It says this part of the quiz will be no calculator. Abruzzo and I haven't decided what we're doing yet about this, but you should practice it no calculator. All right. So think about what this means. Okay, how do you reevaluate this? How do you rewrite this as an exponent problem? 5 to some power equals 1 over 25. What power is that, guys? Yep. The answer to a log can be negative, okay? If you were talking about this question, the only one of these that can be negative is this one, okay? You can't put a negative down here, and you can't take the log of a negative number. All right, back to this one. If you rewrite this, it would mean 3 to some power equals the square root of 3. What's the square root mean? What power is that? 1/2 power. 1/2, right? Square root is the 1/2 power. All right, what about C? This is ln, which is base e, right? Of e to the 7th. So if I rewrite that, e to what power equals, so it's just 7. The other way you can do this one is anytime there's an exponent up here, you can move it out front, and then the natural log of e is just 1. That's one you're going to want to memorize, okay? This, if we wrote it as an exponent question, would say the natural log base e, or which is of some number, equals ln of 5. So what does it have to be? 5. They just undo each other, okay? You know, I could put this on a quiz and just write e ln of 3x, and you got to know the property, right? Because it's not going to do it on the calculator as long as it's got an x in it. All right, this is the same idea, guys. Base 10 and log undo each other, so the answer here is 13. Same as they did here. Base E and ln undid each other, and we got 5. All right. No calculator. So this is 7 to what power equals 7? It's 1. What is this? It's just 5x. Is that a base 3? So the answer is 2. If you're not sure, rewrite this as a log sentence. Right now it says 3 to some power equals x. If I rewrite that as a log sentence, you'd have log base. What's the base in this sentence right here? 3. Of some number equals the exponent. So what does x have to be? 2. Okay. You can always rewrite them if it's not making sense that they cancel out. What's this one? If you are touching your calculator, I would like to break your fingers right about now. Don't use your calculator. What is this asking? What is this asking? 6 to what power is 36? The answer is 2. This is asking 3 to what power is 1 over 81? Well, the fact that it's in the denominator means it's going to be negative. Okay, 3 times 3 is 9, times 3 is, times another 3 is, so that was -4. I have a chart for you of perfect squares and cubes. All right, what do these do? Undo each other, right? So we end up with what? X. Yeah. Anybody have a guess? 8 to what power is 512? I don't think you have this one. Just trying to give you some more practice. I don't think it's... I think 4. It might be 4 because 8... It might be 3. 8 to the 3rd? Okay. What's this one? Log base 4 of 4 to the 3.2. Yeah. 4 to what power equals 4 to the 3.2? So the answer is? Okay. 2 to what power is 1 over 32? Well, because it's made negative because it's in the denominator, but 2 times 2 is 4, times 2 is 32 is 5 times. Okay. 16, oh, this is a tricky one. 16 to what power is 2 to what power? What is that power right now? 1/2. Okay. Can you make this a power of 2? 2 times 2 is 4, times 2 is 8, times 2 is 16. That's 2 to the... Well, 16 is 2 to the 4th, right? Okay. And that power is 2 to the 1/2. How do you get 4 times what is 1/2? 4 boxes is the power of 1/2. Okay, solve this equation. 4x equals 1/2. How do you get rid of 4? Or 1/4. So we get, yeah, this answer is 1/8. I used to put those on the no calculator part. I probably won't this time. Okay, so 10 to what power? This is a calculator question. Can't do that without a calculator. Can you take the log of a negative number? Not possible. Log and base 10? Yep. All right. Which of these are calculator questions? Actually, this is not. Because if I rewrite this, what's the base right now? E to some power equals 1 over e to the third. What power is that? That put it down in the bottom? Yep. Don't need a calculator for that one. These undo each other and you get 4. But that you'd have to type in your calculator in that. You'd have to. Is it okay to have a negative? This is just out in front. So it's just going to be a negative answer. You can't have a negative base or take the log of a negative number, but that negative is out front. All right, you have this question. Like to invest in account, 6% interest. It gives us a formula. It says ln of A minus ln of P equals RT. What do we know? That's her present value, so that's here. And what else do we know? Okay, so where would that go? But we'd put 0.06, good job. It says how long, so we're looking for T, right? Yep, for her account to grow to. So that's the future value she wants. All right, so just type this in. ln, can you just simplify that to ln of 3,000? No, you have to type in ln of 6,000. ln is on the left over here. No, we don't have to graph it. Minus ln of 3,000. Okay. And then the rest of the question says, so we have this 0.69 blobby number on our calculator, and how do we finish? What? Divide, maybe? Divided by 0.06. 11.6 years. Yep. All right. This is a m equals 0.67 log of 0.37 e plus 1.46. Lovely. Where E is the energy released in kilowatt hours. If the amount of energy released is 1, so we're supposed to put a 1 in where? For E. Yep, we're just supposed to put the 1 in here. So this is just a typing question. Can you type this? 0.67 log the LOG button on your calculator, base 10, of 0.37 times 1 is just 0.37, plus 1.46. What's the scale? 1. And it's just the magnitude. Someone else get 1.2? Did anyone else type it? We're really going to trust Keva? I just want someone to back you up that they got the same answer. All right. I'm going to start talking about log graphs just a little bit. Yes, it's on the next page. Is this 3B? Is this at the very top of the page, maybe? Yes? Okay. So what does it mean for them to be inverses. What do you remember about inverses? The graph. Yes, you switch the x and the y in all the ordered pairs, and everything is a reflection across this line, right? So if we had an exponent equation that was growth, the log is going to flip over here and look like this. All right? If we had a decay, it would look like this. When we flipped it across here, it would look like this. Okay? So, I don't think you have this chart, but again, when you had a growth equation like this, the inverse will look like this. So this would be a log base 2 or 3 or something like that would have this shape. If you had a decay equation, it would have looked like this originally. So when you reflect it across that line, if you had something like log base 1/2 of x, it would have this shape down here. All right. Remember that horizontal translations are dependent on inside. Outside, we're good with that, I hope. Okay, so tell me what's going on here. What are these translations? What does this do to a log graph? Left 4. What two things are happening here? There's no parentheses, guys, so therefore the parentheses are like this. Down 5 and reflected across the x. Which do you have to state first? Okay, if I put a number in here, what's happening first to it? If I said the first thing would happen is the negative, right? Out front, it's reflected first and then translated down 5. And this one down here? Yes. First, it would actually be shifted left 2, but there the order wouldn't really matter. All right. This is a log base 6 question that you have on your worksheet. And so basically, its inverse is 6 to the x, so you could find 3 ordered pairs by just putting in 0, 1, and -1. This would be 1/6. And then to do the inverse, you flip them all. So let's try this one. If I want to graph this, okay, without a calculator, get 3 exact ordered pairs, I'm going to rewrite it. What does this say? 3 to the y, right? Okay. So what are some ordered pairs that work there? Can we put in numbers for y instead of x? So if I put in a 1, I'd have 3 to the 1, which would be 3. If I put in a 2, I'd have 3 to the second, which would be 9. If I put in a 0, okay, 3 to the 0 is 1. What about -1 for y? 3 to the -1 would be 1/3. Okay, so now we're graphing them as xy. So we have 3, 1, 1, 0, 1/3, -1. So this ordered pair down here is 1/3, -1. The graph looks like this. If you went out to 9, be just off the end, you would be up to, whoops. Yeah, you'd be up to 2, which is actually up here. It's counting by a weird scale. All right, so what can you tell me about this graph? Domain? Not all real numbers. It's the inverse of the exponential growth function, so it is, look at the graph. X values left to right. Range is y values bottom to top. That's all real numbers. It's the switch from the growth equation. You're switching domain and range because we switched x and y. Intercepts, it only has an intercept on which axis now? X-intercept at 1, 0. End behavior, as we go to the left, it's getting, does it even go to the left? No. Okay. It would be going to negative infinity, but it actually doesn't go, there is nothing to the left of there. As we go to the right, it's a, all right, what about this? What two transformations occurred to this graph? Okay. First, you do what's in the parenthesis, which is shift it right 2, and then what? Reflect over x. So the shape, where's the asymptote going to go if we go right 2? Yeah, we didn't write. What was the asymptote on this graph, guys? But it's x equals 0. It's the y-axis. All right, so let's move over to this problem now. I think we finally get, oh, was this one increasing or decreasing? See, I'm hopeless. I can't get, what was this one doing? Left to right, it's increasing. Okay, back to the one over here. So we're supposed to shift the asymptote 2 to the right. So what's the asymptote going to be? X equals 2 is our new asymptote. All right, and what one point would be real easy to do? This intercept is 2 to the right, which would be right from 1, 0. We move it 2 to the right, it will be 3, 0. So the x-intercept is 3, 0. Now, the rest of the points I can't just shift to the right because I have to flip them as well. So what's the shape going to look like? It'll be the other direction. So this point up here that was at 3, 1, okay? It was at 3, 1. If I move it 2 to the right, but then I have to flip it up, 3, 1 would be here. Then I have to flip it upside down. The shape is going this way. I'm not going to ask you a question like this unless you use your calculator anyway. But there's, be going that way. Okay, just, what's the domain real quick? I don't want to do all of this, but what's the domain? Two to infinity. Okay. Other than that, I think you could figure it all out. All right. We will do some more on these tomorrow. Tonight, you need to be working on the second assignment in your sheet. It's some application questions from page 166 and then starting on 178.